Welcome, I'm Bill Wake. We're working on a program that's going to be a compiler for the 10th language, which is a subset of 4th. We've done a fair bit of the interpreter side. Now we're doing the compiler side. And I think what we want to start with today is the ability to take routines that are meta, meaning they're more about the running or building the compiler, or I guess they're about compiling and other things that always happen, as opposed to regular words, which sometimes get compiled and sometimes get run. So we need to identify if a routine is a meta routine and make sure we run it regardless of whether we're in compile mode or execute mode. Okay, so let's just make sure where we are. We should be good. We created a test, but it didn't do anything. So let's find that test. Develop a way to write secondaries to the dictionary. Well, I think these are meta is the word I'm using now. And I think that's what we want to do. Secondaries to the dictionary. Well, let me talk about those too while I'm in the intro here. Okay, so we'll write some sort of routine that walks through and tries to figure out if another a method name is already a meta routine. That's the easy part, I think. Then a little trickier, maybe not bad, but we want to do the actual compiling. And so our secondaries, they look like on the left. The first cell is a link to the previous secondary in the dictionary. The next one is the link to the name of the cell or of the word we're looking for. The third is the address of the start secondary code, because this is going to be a secondary. And then the rest of it is a list of addresses, and they're going to point to other primaries or secondaries, and they're going to point to that third cell, the address of the code. Finally, the last entry is a link to the N2D, end secondary word address. So compiling then is pretty simple. I mean, it's about as simple as you could get and still think it's compiling. So I'm imagining some sort of start secondary that when we see a colon which defines things is going to have to go to the next word and say, what's the next word I'm going to parse? That's the name of the word being defined. And its job is create the first part of the header. So it's going to write the system dictionary, the current system dictionary, to the next free space, which we haven't figured out where that is. Then it's got to save the name and write the address of the name to the free ++. And I guess actually then it's got to write the address of start 2D. Okay, so fill in the rest of that header. And then add secondary is just going to add things to that list of addresses. So that's pretty easy. And then finally, end secondary puts the N2D on. And actually, it should probably update system dictionary too, because at that point, we've completed a word. If we had some sort of syntax error or something, we wouldn't want to update the dictionary until we get to the end. So I think that'll be okay. But let me add that in there. Okay. Update system dictionary, and that's in a register. I'm not going to worry about which one yet. Okay, but that's the kind of thing we have to do to compile. So, I mean, the old word of compile, meant just kind of like gather things together, and that's really all this is doing, is kind of gathering addresses of subroutines. The if statements and repeats and stuff are going to make a little complication, but not terribly. So it's a nice simple compiler. Not a lot of syntactic complexity, not a lot of stuff going on. All right, but first, the meta. All right, I don't know where that last test was. Not input, I don't think. I think we're done with input for now. I think the next thing for input, we're not doing it today, but at some point we need to be able to recognize numbers. Especially numbers that aren't in the dictionary, I guess. And we also need to recognize strings, but we haven't defined any of what that does yet. It won't be too hard, but that's the next time I expect to need input. C-like What did I feel like no, I don't think we need anything there. All right, REPL tests. Well, we're not doing that yet. Okay, where's core tests? Oh yeah, start colon enters compile mode. Well, colon's going to do more than that. Boy, I thought I put a test somewhere. Oh, unit test demo is just our playground. You know, maybe I'm going to rename that. Playground. Okay, so it's not anything we really run. Oh, core tests. Okay. Let's see what's up with core tests. Colon enters compile mode. I don't care about that. Oh, yeah. Okay, so that does fail, right? Okay, there it is. Thank you. Yeah. Okay, is that what we want to check right now? I guess we're checking. Yeah, I mean, that's something that has to happen. There's more to colon than that in the long run, but colon is really the trigger for our start secondary stuff. Okay, load address, colon, print. Okay, yeah, that's all we're doing. All right, fair enough. That's a good test to do. Colon enters compile mode. Okay, so we want to just execute colon, and it's just a routine on the stack, and we're going to set the flag false before we go in, BL colon, and then check things. Okay, I always like my tests on the left for some reason. Okay, so the heart of this thing is BL colon. Get my hands in the right place. BL colon. All right, and the setup. Let's go back to our design. You know, I did make a change. Let me see. I'm all over the place today. I put this together. EnvironmentNotes.key. Oh, let's get over here. Huh, I guess I didn't add it to the project. Okay, and then I guess open an external editor. Okay, what I did is I went through and pulled out all those pages I keep referring to that are on the bottom of things. So the addressing modes, calling standard, registers, assembler directives, LLDB, a couple of things about instructions, and some documentation. So in this case, we're well, I want to do the same thing for the design notes, but I haven't yet. Let's find those. I'll probably do that offline tomorrow. Somewhere in the last week or two. Yeah, there we go. Okay, so we have the flags x24, and if you'll recall, we created constants for those. So we're going to set x24 clear and then verify that it's compile when we get done. Okay, so and it's run mode. Where'd REPL run mode? Okay, so we need to import REPL.macros. Run mode, compile mode. Okay, I can probably remember that. All right, and then x0 gets x24. Compare it to compile mode and assert equal. Okay. Yeah, that test, colon enters compile mode. It's in there. Okay, that should run. It'll fail still. That's a little too hard. Underscore colon. I'm not sure my naming standard is helping anything, but all right. So core tests. And I think I can just run them. Yeah. Okay. So we expect 0. We expect 1. We got 0. And this is core colon. We can do it at the end here. X24. Compile mode. Okay. And then, well, that should pass. Why are you okay? Oh, did I not include that? Okay, where's my core test? There we go. Colon enters compile mode. We got a little printout because that's our what we're doing now. I don't think we need that print anymore, though. It's it was handy for making sure things did things, but let's take it out. Colon print. Okay, core tests, all good. Good. And then we want a semicolon test to make sure we exit compile node. Very similar. And I'm gonna say it differently. Switches to run mode. Okay, semicolon. We're going to start in compile mode. And we should exit in run mode. Get compile. Yeah. Oops. All right, fails. That's fine. We expected 0, we got 1. That's what we hoped for. Guess I should be saying that before we run it, but we'll get there. All right, so this one, and I think we're going to delete the print as well and move X24 gets run mode. Semicolon switches. All right. Now, we have an oddity, I guess, that if you enter... Yeah, here's the oddity. Let's run our REPL. Okay, so I'll do one dupe colon add one is going to be defined as one dupe add semicolon, and then we're going to call add one. Now, I think we're probably okay in the long run with this, but what I think is going to happen, well, let's do one dupe multiply, or what else can we do? Well, multiply is boring. I guess add again. Okay, my prediction is if this did what we wanted, it would be one on the stack, 1 1. Define this, one dupe add 1 1 1 1. Add is 1 1 2, and then one dupe add is 1 1 is 2 again, and then add is 4 with 1 1 underneath it. All right, what I think is going to happen, we're not going to get a 4. I think we're going to get a 1, because I think it's going to run one dupe and then go in colon into compile mode, but semicolon doesn't run in compile mode. Nothing does. So I think we're just going to stay in compile mode and not get a 4 on the stack. Okay, stack is just 1. Now there's too many things. Oh, no, we print the stack after every word executes. So you can see there's clearly no one dupe add gets 2 kind of things going on. So this is the fact that we don't run meta commands even in compile mode. Okay, so let's get to a REPL. So eval all, right? So it says, are you in compile mode? If you're not, then it goes to evaluate. If you are, it goes to the compiler, which is held in X23. Now, whatever our compiler is doing, actually, I don't even know. Oh, we have the compile routine. Okay. But notice it just returns. It doesn't do anything. So compile is just throwing away every command that comes in, including semicolon, because we're in compile mode and we don't evaluate in compile mode. So what we really need to say is, well, it doesn't need to know semicolon. It needs to know, are you a meta word? Okay, so we'll have the same thing with if, right? If you did :def some word, colon some word you want to define, and then if condition, then do this, else that. Well, if needs to run at compile time. I mean, we had to compile the if into something to run it. It's going to be a little confusing, but there's 2 levels of if statements there. So we would need to compile the if and, push an address somewhere and then go backfill a patch to it and stuff like that if requires. But that's all compile time activity. It's not a runtime thing. There is a component at runtime, but it is also one at compile time. Just like when you compile an if statement down to assembly code, the compiler deals with it as an if statement, generates the assembly code, and then the assembly code runs and does compares and branch if equals and stuff like that. We're going to have the same issue. So right now we have no way to exit compile mode because we don't know our metas, because if it's not evaluate, if it's not compile mode, well, we also need to do meta as well. So if you're in compile mode or you're looking at a meta word, then you should evaluate. Okay, so if it's not compile mode, I may want to switch these around, but if it's not compile mode, go to evaluate. That's true, but we also need to say if it is compile mode and you're a meta, you should also go to evaluate. Okay, so I mean, I'm kind of predicting the code for this is a couple more, compare and a branch. But to do that, we need an is meta, and I think we'll do is meta first, and then fill in kind of from bottom to top here. All right, so I know I want to ask, are you meta x0? Now we're going to have to do some saving because are you meta is going to have to be a routine. So yeah, that's the way it goes. All right, but let's see. Where's meta go? I think it goes in here. Maybe it goes in main. Yeah, maybe that's the right place. We have the headers going in. I think we could probably add a flag on here to tell if it's meta or not. Yeah, I think that would do something. Okay, so that's how it runs, but where it runs, I don't think we're doing main test per se. No, see our main. There it is. I think a REPL test is probably okay. Let me sort these. Okay. Yeah, I think we'll put it in REPL test. Well, maybe it's a dictionary thing. Yeah, I mean, it's dictionary macros. Okay, there's different ways to do it. So, let's see if I can get my picture of this. All right, so our dictionary for primaries looks like this. Somewhere we have the end of dictionary pointer. It points to the last entry, and then they keep going down, to the previous ones. The question, if we put it in the dictionary, it's like, how does it know? The only person that needs to know if it's meta is the REPL, because it's part of the I mean, there's no true separate compiler like there is for C or Swift or something. It's kind of the environment putting it together, and the environment is deciding, hey, am I in compiler mode or am I in run mode? The REPL's deciding that, and so it's really the only one that queries that. But my choices are pretty limited, right? I mean, all I can do, well, I shouldn't say all, but one way would be to expand the header and put an extra byte in there to contain a flag that says I'm meta. There might be other flags we would like to have for some reason, so it may not be a total waste, but it's adding another word. Okay, so I'm not super thrilled. The other way would be to take some bit and put it in there for that. Now, we can do that because the least significant bit of these things, we can pretty much arrange that they only point to whole words. So they're, especially code, has to be on 32-bit boundaries. So I know that anything that's an address of code has got to have the lower 3 bits are not going to be used, because we're going to maybe it's the 2 bits. I don't know. I'm getting confused, but at least the lower bit is not used. We could use the bottom bit of a pointer to represent the fact that it's meta. Now, we can't do it on the name routine because that's pointing to bytes and they can be anywhere. But we could enforce our dictionary to start on the right boundary. And so the link to previous would be a candidate. And in a way, it's a dictionary attribute. It's like I can kind of see it. Or the address of the code. We know the code has got to be on a 32-bit boundary. So the lower, I guess that means 4 or 5 bits, right? Should be available. We only need 1. And then the next place there is ARM architecture actually has tagged pointers. So because a 64-bit address space is huge, right? It's way, way bigger than anybody's got on their systems at this point. Maybe theoretically you could, but a 64-bit space is way, way, way big. 32-bit is not. I mean, that's your 2 gigabyte limits, right? Or 4 gigabyte limits, depending what you're doing. But, that's an issue now. It wasn't 20 years ago or something, Actually, I can remember being on a project where they had a terabyte of data and, an 800 gigabyte drive or something, or maybe it was gigabytes and whatever's, but, they were running out of space. And, at some point we had to switch over to bigger address spaces, but 64 bits is, huge. And so ARM has, I think it's 4 bits. It might be more, might be 12 even. I'm not sure, but it has some number of bits. And, those bits can be used as tagged values. And something I saw said that Objective-C actually does that because it needs 3 or 4 kinds of pointers. They need to keep track of what kind they're doing, and it uses that. So it's an option. But I don't know what happens when you are those filtered off when you use the address, so if we put it in the high, bit 63 or something, bit 60, does the system just mask off those top few bits that are tags and then let you access it? It's actually supposed to restrict you, you can't load, you can't do an add of this tag with a different tag or something like that. So you'd have to, either the system strips it or you would go in before you followed that pointer and filter off the bit and say, this only take the lower 51 bits or whatever as the pointer, and then follow that. All that stuff's it sort of puts itself in the way all the time. I'm thinking of a cheesier implementation, which is, let's just have an array of pointers to names, and that the value gets put there. Now, I don't know. In our assembler, it doesn't make it easy. So that's really annoying. Now, our dictionary stuff, if you recall, we're actually doing this at runtime because we can't get these addresses of routines and stuff like that in the place we want them. Okay. But what I'm thinking, I don't know, it may, sort of a lookup table kind of thing. Just throw these into a separate list of pointers on the side, and we'll have a pointer, put kind of like we did the other day with our test case where we put a bunch of stuff in a row. I'm thinking put a bunch of pointers to the names of these things in this table, and then just walk that list and do string EQs to see if if I'm doing colon or semicolon, at this point, that's the only two we have, then actually word not found error kind of is too. But anyway, those would be on the list. You do a quick skim through the list. If any of them showed up, if it showed up on any of them before you hit a 0, then everything's good. So yeah, a special meta dictionary. Although dictionary is kind of, I'm thinking like linear array, array of pointer string. All right. And I think we can do it with the macro. Like maybe we define, I think we can say like that. We can put a phrase in there. And then maybe a regular or just default it or something. So let's look at, we're exploring at this point. So we're going to look at dictionary macros. And my question is, can I have this name here. I think I could write a little if statement. If it's meta, then load address this header name, which is the name of the string, and then append that to some pointer, some space we're pointing to. And at the end, we'll put a 0 at the end of that space. So do I need another variable or another register? We're going to run out if we use them for every little thing. So I'm thinking maybe just put this as a word address kind of thing. Put this, put the variable that holds them in a in-memory variable, not a register. And again, I don't think the overhead of this happens once in the main loop. These are 1-2 words right now for each one. Oh no, 2, 4, 6 instructions. Okay, it'll probably be a little more. All right, now to test this, I guess we're going to look at our dictionary tests. Empty dictionary has zeros. Okay, edit to dictionary adds item. All right, so I think we're going to have kind of the same test. All right, and then the adding to dictionary with meta marked. How about adding meta to dictionary? Okay. Now, dictionary init, dictionary header NL. Okay, and I want to add something that says, I got to somehow flag that they want to do this. I don't know if I can do it at macro time. We have if, don't we? If expression, if symbol. No, it's not good enough. Okay, well, I think we'll have to do something that they will trust. Okay, so all right, so dictionary init is a method. Well, let's get dictionary up here too. Okay, put the tests here. Dictionary init. Okay, so it loads the system directory. Okay, yeah, I think. All right, let's. How do I write the test first? I guess we're calling dictionary init should set up whatever this pointer is. If I say this with meta, how's that word going to help? Well, dictionary macros. Okay, let's define it in there. Equal meta true equal regular false. 1 and 0. Okay. And our test can use it. It's marked meta. Now that's going to blow up at compile time first. Okay, but then I think what we want to say is well, let's make it colon just to be kind of semi-realistic. Okay, so we want to put the colon in the dictionary with this routine, and it's a meta. All right, and then we're going to have a meta pointer, meta root. Okay, so we'll load address x0 is going to be meta root, and then how's that going to work? Well, there should be a meta root pointer too. Okay, so meta root, meta start. All right, that's going to be the start of the array. Okay, and then address x0 meta start root is the place we're going to start looking. Well, no, they're the same. Now, let's see what the assertions tell us. All right, somehow meta start well, meta start's a variable. I guess I want to say loader x0 gets contents of x0. So I want the contents of that cell, and then that's a pointer, and then I guess I need some data here. Well, we'll put it up at the top. L colon string. Colon. Okay. That has to be a string like that. Okay, that's okay. But loader x1 with L colon string. No, it's got to be a load address. We'll load x1 colon string. I want to do BL assert equal strings. Okay. Maybe this is meta next. Okay. And then I want to assert meta next moved. Something like that. Okay, so if you initialize the dictionary, you create a colon entry that is meta. If I look in the meta dictionary, the meta list, at the start, I get the address of the meta start. I load the string it points to, the value it points to, which is a pointer to a string, hopefully this string, and I compare it to L: string, they should match. So L: string should be in the dictionary. All right. And then meta start. Okay. Let's do meta next. X0 meta next. That's where you should write it next. That should be, let's take the address of X0 meta start and add, whoops, X1. Add X1 equals X1 plus 8. Okay, so I should have written the :1 in the first slot and moved the pointer down to the next slot. And at the end, I don't think I have an end right now. Okay, I probably should. Okay, but let's get the test going. All right, and I guess I want to say dictionary end should be done. And in here, these two should be assert equal, just numerically. The meta start should be meta next. No, meta next. Yeah, meta next should be meta start plus 8 bytes. Okay. And those should be equal, and load address X0 meta next. The last entry move X1 gets 0. That should be equal as well. Okay, this will not compile. Whoops. Yeah, we don't have meta used and we don't have dictionary end. Okay. So meta is defined in our dictionary macros, but it's not accepted on the dictionary header macro. Now, I think, let's see, macro. I don't know if they have enough examples in here. Yeah, you can do equals. I don't know what you're allowed to put in there. Equals default. Okay, so code address is meta equals regular. Is that what I call it? Yeah. Okay, so if you provide a meta of meta, it's non-zero if it's meta, and it's 0 if it's regular. All right, and then we need a new dictionary macro. Macro, I don't know if we really need this, but it's kind of a nice way to do things. Okay, and right now we don't do anything. I can put a no op there just so we have something text-wise. We don't have to do even that. All right, I believe we should make a compile and fail. Okay, what do we got? Undefined symbols, meta next, meta start. Okay, good. They need to be defined, and we'll put them in dictionary. Okay, so meta start is going to start out quad 0. And then meta next well, I think this is the one that needs to be a fill. Let's yeah, how many? Let's do fill 300 bytes. Well, these are pointers, so they're 8 bytes each. How many metas do we have? 10? We probably have 20, but maybe, I mean, we might have 15, but not 20, I think. So let's say 20 times 8 is 160 bytes at 8, 0, that. Okay, and then meta next, that's actually, in a way, meta start's not the right name, I think. Meta list, maybe. Meta next I can live with. It's a quad 0. Okay, it's the pointer to, it should be pointing to meta list, and now dictionary start is going to have to make that happen. Okay, and then we got some space. Yeah, I'm going to point to the strings that get used in the definitions, I think. Okay, but let me get this straight out first. Meta list. Okay, now we should build at least something's found. Meta list is referenced from dictionary tests. Oh, they need to be globals. Okay, and then, am I there? Meta list, meta next, meta start. Okay. Oh, missed one. Undefined symbol, meta start, referenced from, oh, this should be meta list. Thought I caught them. Okay, so if you look at the meta list, all right. Okay, somebody should have failed. What was it? Dictionary tests. Oh, did I add the tests? I probably didn't. Okay, there's a good failure for you. Okay, yeah, let's point. All right, so the setup, where are we? Adding to dictionary, adding to meta. Okay, so the dictionary init should initialize meta start to point to meta list. Okay, so let's make that happen. Okay, so we'll load an address. X0 is meta. Well, let's load meta next first, and then load address meta list. Okay, and then we want to do a write. We want to store meta lists address in meta next variable. Okay, so meta next is the pointer. Pointer to next slot in meta list. Okay, and that, does that do anything for us? Well, it may get something. Segmentation fault. Okay. I think that's the right setup. Now the test says call dictionary header with the meta. All right, and then dictionary end. Well, dictionary end, I think it should write a 0 at meta list. No, at meta next. Okay, so meta next points to the next slot in the dictionary. We're just going to write a 0 in, so we've got an M to our list. All right, load address. X0 is meta next. Store a 0 at meta next. Okay, so we've been moving meta next down as we go, and at the very end of the list we want to put a 0 so we can search it. All right, now I think this should still fail like that. Yeah, because we're assuming it's there and we follow a pointer and there. Do we need to load the address from meta next first? Well, meta next should, am I doing this right? Meta next is a pointer to a slot in meta list. I've got the address in meta next, so I think I'm going through the contents to the 0. Do you think I'm not? I mean, I think I'm writing a 0 where meta next points to, I guess, is what I'm trying to claim. All right, but that's still, our test is not ready to deal with that, right? Because, okay, so actually it's dying right here, right? It's not finding a colon string at the first entry in the meta list. Because we haven't done anything in the header. Now, load address meta next. Okay, so the address should move forward. And I think this one might pass. So I'm just going to move it up momentarily. Let's see if we get one pass. I think we will. Okay. Adding meta to dictionary. Well, we get a fail. Which sounds like I'm writing to the wrong place somewhere. I've got the address of meta next. I don't have the contents of meta next. Is that the one you're talking about? X0 gets address at X value at X0. That should be a 0. Yeah, there's my first pass. Okay, so I think we're writing the 0 byte at the end, or the 0 pointer at the end correctly, and testing it correctly finally. Okay, but we're not doing anything else. Okay. So the rest of this, making sure the colon string gets somewhere, that's the thing that dictionary header should do, which is a macro. Okay, so we wrote these code addresses. Dictionary header at I almost think it belongs here. X0 is still the address of the dictionary header. All right, so I want to say compare is meta to meta. And if it's not equal, I'm going to skip meta. Well, that should be an L. Probably should be an L at, right? Because every one of these is generating its own. Meta-next is the address of the address to the next slot. Okay. All right. So if it is meta, I've got x0 sitting there containing the header string, and I want to put the pointer to that somewhere. Okay. So that's the meta stuff. I'm trying to set the last entry. So you do a bunch of headers, some of them right to the next array. And then when you say dictionary end, I want to write a 0 as the last entry of that array. Okay, so I can walk through the list of pointers and stop when I hit a null. Okay, I've got the dictionary header, so I'm going to load address 1, x1, with meta next. Okay, so I have the address of meta next. And then somewhere I want to store x0 into, I don't know if it's meta next. Well, I want to store it into x1, right? No, I got to load one more, right? Contents of x1. Okay, so now I have the pointer in x1, not the pointer to the memory. Okay. These dereferences will kill you. Okay. Not the value in meta next. No. The value wherever meta next is pointing at the after the last entry is the next cell that's supposed to be ready to take a string, but if we're done, it should have a 0 in it. Okay. All right. So I may be mixing things up here. I get the address of meta next, which is a pointer. I dereference it once, which now gives me a pointer to the slot, and then I store x0 at that slot. Okay. And then I think I need to increment meta next. So maybe this is, let's put this in x2, write it to x2, increment x1, no. Increment x2 gets x2 plus 8, and then I got to store that in x2 in the address of meta next. All right. I don't know. It's a lot of stuff, isn't it? All right. Meta next is a variable in memory. I'm going to load its address. I'm going to dereference it once and get what it points to, which is somewhere in meta list. I'm going to store the string at that slot. That's 27. 28, I'm going to move the slot pointer down one word, and then I'm going to store that slot pointer back in meta next. Okay, I think that's a lot to get right in one go for me. Okay, so dictionary header, right. I think, oh, and have I done dictionary end? Store the 0 at meta next. Okay. I guess my claim is I think this should work, but okay, can't even do that. Invalid operand for instruction. Oh, slash. No, there's more to it. Compare regular to meta. Do I need cab? While in macro instruction, dictionary test 55. That's down up here. Okay. While in macro instruction. Well, no, he's kind of doing the right thing. Okay, did I save that? I don't know if I can just not, if I can't compare these. Constants? Yeah, that's a question, right? It could be this kind of thing. It's like it's not picking up that value. Is that possible? Dictionary macro defines them. Dictionary tests refers to the macro. Dictionary certainly must. Okay. Well, maybe I gotta load them. That seems obnoxious. Oh, did I lose my preview? Okay, one sec, sorry. I never know what I was looking at. All right. Well, let's find compare. XN RM R is a width specifier. Okay. Maybe I have to load them. Well, that seems like a real pity. Maybe this if will work for that, though. Let's see. If def, if not def. No. Well, okay, let's load them and then we'll deal with them. Oh, I hate doing that. Okay. Move, let's see, x0, x1, x2. Let's do x3 and x4. Okay, move x3 is meta. Move x4 is meta. Compare x3, x4. Okay. Let's see if it likes that better. Yes. Okay. Oh, now we're not crashing. That's a good sign. Okay, 429-7902-51228. So they're off by 16. All right, but the first pass, let's see what our tests say. The first pass, did I run adding meta? Yes. Adding meta. Okay, the colon is in the right place. So we did put a colon string, a pointer to the colon string in the first slot. Woo. Okay, now I'm looking at x0 meta next. So we load meta next and load meta list. We're saying x0 is meta next. That's the, oh, maybe that's got to be the content of it. Yeah. x0, contents of x0, that should be what points to somewhere in meta list. Okay, and then meta list itself. Okay. Yeah. Let's try that. No. x0 equals 0. What am I? x0 is the contents of meta next. x0 is the address of meta next, and then when you load it, it should be pointing in there. Dictionary needs to load our x1, x1. Dictionary end. Load address x0. I think I can just do x0 here, right? Yeah. Okay, so before we were writing a 0 into meta next, now we think we're writing it into whatever meta next points to. Okay. Oh, now that one's 0. That number seems suspiciously high compared to what we got before. All right. x1. x0 is meta next. x1 is the contents of meta next. Am I missing another layer there? x0. Okay, I've got meta next somewhere. I've got meta next sitting there. It points to something. So I load its address, and then I load what it points to, which is some address. I think I got to do another one of these. Double dereference. So load the address, get what the address points to is a pointer to somewhere in meta next. And then I take that pointer into, meta list, take that pointer to meta list. The contents of that should be 0, I think. Yeah. Okay. Good. Maybe. All right. But we've got our meta list writer. Okay. Now I'm going to make another assertion in here. Well, what I want to do is make sure this thing does not have a meta entry. How can I do that? Okay, so that one, I think the easy way to write this test, what I really want to assert is, in addition to all this stuff that puts it in the dictionary, which is good stuff, I probably want to make sure adding a regular item does not create a meta entry. I think if I write the is meta routine first, that assumption will be much easier to test here. And maybe it's a separate test. It's just an initialize and go. I do think though that we've changed the interface to things, and really you need to do this at the end every time you use dictionary header, unless you're building it and waiting. Okay, so let's look for dictionary header. Okay, the macro defines it, but this one's the one that really needs it. Dictionary end. Okay, main. Got a bunch of tests. Let's get those in shape. Okay. REPL tests. Okay. Those should still be good. It shouldn't hurt them. Okay, now make REPL 1 dupe colon. We don't do anything with it. We don't have anything in our list. Add semicolon add does not create a 2. Okay. Good. Okay, so we modified dictionary header to accept a meta flag, making a list of all metas. All right. Now I want to check is meta. Okay, adding meta to dictionary. I guess right after that's probably good. Okay, so test start. Meta finds names. Okay, and then like that. Okay, we'll put colon in the list. I think we'll put semicolon in the list. And I'll check both those. And I'll check something that's not in the list. Okay, so let's put a little data. L colon string, L semicolon string, L not meta string. Okay, and if I call, let's load x0 with L colon string, and I call is meta, then I should get x0 is the result of is meta is either 0 or 1. I want it to be a 1. So let's load x1 with, this is a Boolean result, so I think I should say 1 and be able to assert equal. And I'm gonna, normally I do a range act assert, one assert, or one block of asserts. In this case, I'm going to combine these because they have such similarity. I don't know. It may be. Okay, so let's look for semicolon string. That should be a 1. And then let's look for L not meta string. And that should be a 0. Okay, address the found word in meta list. Yeah. All right, so is meta should start existing. Dictionary in, dictionary search. Let's do is meta, return, and global. Okay. Now, all right, that should fail if I add it to the list. Well, meta finds names. I'm going to work on that name. Is meta finds only metas. All right, should be a perfectly good failing test. Oh, not that good. Oh, load address. Okay, some failures, which are fine. Okay. Yeah, we could. Maybe that's worth doing. It would help a little. Let's see. So, yeah, let's take a minute and do that. I really should start a documentation page. I don't know what this is. For this too. I don't know if anybody will ever look at this again, but if they do, they'd like to know some things. Okay, so that's the macros. Is that it? Assert equal should return that value. Let's make sure that's true. Yeah, okay. But the real thing is it prints message. Okay. Let's try those here. You're right. Well, we should implement this one too. They should still fail. Okay. Well, we're not doing anything yet, so that's okay. Let's take a break first. We will come back and write our is meta. We don't do anything in it yet, so let's do that. 3 or 4 minutes and we'll come back to it. Welcome back. Okay, let's do is meta. Right now, I think we're passing in L colon string is what's in X0, so nothing good there. All right, it's in dictionary. So is meta search for string in meta list. Return 0 if missing, 1 if found. Okay, and input X0 is pointer to string to search for. Output X0 is 0 or 1, false or true. Okay. All right, so we need a pointer. Well, we're going to call a routine, so we're going to have to do this stuff for sure. I think it's likely we need another pointer as well. Okay, so we want to load address X1. I want to get our meta start. in a list. Okay, so that's the address of a pointer to a string, and x1's gonna keep track. Maybe we need to. Okay, well, let's see what we do. It's a pointer to the address of a string, so we have to load it again. Let's load x2 is the contents of x1. Okay, now we have, I think I'm going to have to look at where'd that other one go? Let me get the environment one up. Okay, x1928 caller saved. x30 callee saved. Well, x28 is still available. We'll use that. This I don't need. Okay, so let's do x28. But to do that, we have to save it and restore it. It's SP plus 8. So, yeah. Okay, so x28 is callee saved. And so we use it. We have to save it too, because we're not allowed to destroy it on somebody. Okay, so now if I've got x28 points to meta list, I want to load what it points to. Well, I want x1 to get x28, because x1 is what string EQ needs. Okay, so well, we got more to do. Okay, string EQ. Well, somewhere we're going to do L is meta and that gets us to return. Okay, so if the result of string EQ is it's found, well, if I thought I could compare this to 1. x0 2 well, I can compare to 0. Z XR. Okay, if it's equal to 0, well, if it's not equal to 0, then we're going to jump down to meta found. Meta found says move x0 gets 1, right? So is meta returns 1. Okay, if it's not found, then we need to move x28. No. boy, I'm getting my pointers mixed up. What are the odds? Okay. X28 points to meta list. That's the first entry. Okay, so now I need to move to the next entry. So I need to add X28 gets X28 plus 8. And I need to branch back to L meta keep looking. Got that in the wrong line. Okay. Now I'm losing something that I can't lose, so X1 for 0 and move to is meta end before. Yes. X28 is meta list. Okay. Okay, so contents of X28. Yeah, I think that part's okay, but you're right. This is kind of a compare X1 to 0. X1's the contents. Okay. If it's equal to 0, well, if it's not equal to 0, we want to do the string compare. So this is L compare string. Yeah. Yeah, this is a not found case. So we want to move X0 gets 0 and branch to the end. Okay, so we load our pointer. X1. Well, we're gonna have to load. We're gonna have to keep X0 around because string EQ mucks it up. But let's see if we get the first one. Okay, so we load whatever pointer to a string is in there. If that string pointer is 0, we're gonna do this code, which is set up the return false and then jump to the end. Okay. Then we're going to compare if it's not 0, then we're going to compare the string. We'll branch string EQ. We'll compare the result of string EQ to 0. If it's not 0, meaning it's 1, then we'll jump down here. If it is 0, that means the string EQ failed. So we'll increment X28 to the next meta list and go around to keep looking. Okay, I think this will pass one of those tests and blow up on the others. Yeah. ZXR. Is that not right? Well, it liked this okay. Okay, yeah, so we passed our first one. So that was finding the colon, which works because it's there and the loop doesn't have any problems. But when we go back up here, notice X0 is destroyed by string EQ, so it doesn't point to a string anymore. So I think we're going to have to store X27 in SP pound minus 16 bang, and then move x28 7 equals x0. Okay, so string EQ is not allowed to destroy x27. So I think we should be comparing x27. Whoops. Well, we needed an x0, right? So let's move this around to put the string back in x0. Okay, so I don't know, a little twistiness. If it were a dictionary pointer, yeah, but we don't know that string coming in, this is before we've parsed it or anything. Yeah, you're right. If we looked it up first, yeah. So right now x0 is going to be somewhere. I think it's still in the input buffer. Yeah, I mean, we're evaluating something that string comes with from the input buffer. If it's in the metas, we're going to treat it, we're going to do it for evaluation. Really, the dictionary lookup does need to move up. Yeah, we don't know at this point if the word is in there or not. But if this, well, let's see if this change works. Yeah. Keep typing that. SP. Did I do my loader? No. And I think the routine right before us did the same thing. Yeah. Yep. Okay. Yeah, it would be nice if we did. Now, is that going to be true on the secondary words? Well, secondary words aren't metas. Okay, so we're not letting you define your own metas. So yeah, this would be fine. Okay, let me write that down as a to-do, because I think that's a good, not exactly optimization, but sort of an optimization. Look up words before REPL tests for is meta, so we can simplify is meta to compare pointers directly. Okay, yeah, that's a good insight. I mean, if I was doing this on a Commodore 64 or some little microcomputer-y mini computer kind of thing, we definitely wouldn't waste the opportunity to cut that back. But I think for now, this should work. I mean, I don't know if it does yet. I don't know if I saved. Oh, can't. If this works, I want to move on. I guess that's the thing. But I do think that's a good change. Once we have everything kind of passed through, I'm happy. Okay. Right. And these are dictionary tests. Okay, passing meta as meta finds only metas. Okay. So now I think our dictionary test, we can see. Okay, let's check this in. Let's make REPL first. I think if I do one dupe, colon, add one. Well, let's pretend we're defining multiply. I don't want to screw it up with a word that doesn't know yet, because it doesn't know how to build them. Okay, so multiply. Add one add, right? Should one added whatever semicolon add should put 2 on the list. And I guess whoops, stop. Add should leave 2 on the list. Oh man. Let's see. Add one add. That's 2, 3. And if I just do an add, I should get a 2. Okay, so I think it should do the 1, do the dupe, see the colon, enter compile mode, see multiply, but not execute it. Add, don't execute. 1, add, don't execute. Semicolon, oh, we're back in execute mode. Add, and should do the 2. Oh. What does this mean? Oh, we don't call as meta yet. Okay, that's fine. Let's check this in. We add test for is meta. Okay, now REPL needs that, or we built it because REPL wants it. REPL, yeah, eval mode. Now this is eval all, so we can check this. Okay, so if we're in compile mode, if we're not in compile mode, jump to evaluate. All right. Otherwise, we're compiling. Well, what if we're x0 is okay, x0 is not used. Or is it? We didn't tell ourselves. Eval all. Oh, it is the read word. Okay, let's document that. Well, we're certainly calling stuff, so we need to save x0. Well, can I? Well, let's save x28. Is that what we did before? Yeah. I think it's like that. SP pound 8. Yeah. Okay. Right. So I think that's just refactoring at this point. Okay. And make should be, whoops, Should be fine. And then make REPL. It just stores more, shouldn't hurt anything. One, dupe, add. Okay. All right, so I'm going to put the code in, try it manually, and then we'll backfill a test. I think it's a straightforward comparison. Okay, so at this point, x0 is our word, and we call BL is meta. And well, I guess we'll compare x28 equals x0 is now our new local. Compare x28, no, compare x0 to 1. If it's equal, then we also want to evaluate. If it's meta, branch down here. Okay, this is my cheat. All right, so 1 dupe colon add mul sub don't matter semicolon, well, let's just do mul. 1 dupe mul ignored followed by add should leave 2 on the stack. Oh, okay. I don't know what I'm doing. Okay. Branch meta. If it's a 1, it is meta. We want to evaluate. Okay, so I think this piece is what I put in. Let's make. I don't think that should affect anything. Okay. And then let's check it in. Save x28 in REPL all. Okay. Cynthia Roberts, hello and welcome. So what we're doing is we're implementing a stack-based programming language, somewhat like Forth. I don't know if you've run across it, but it does most of its work by pushing values on the stack, popping them, and then it has some loop constructs and stuff. We're trying to implement an interpreter for that in assembly language for ARM64, and we're at the point now we're on the main REPL, so this read eval print loop, and we're trying to build the compiler piece of this. So what happens is if you're in compiler mode, only certain words get executed. We call them metas, and they're things like define a procedure or finish defining a procedure or do an if statement or an end statement. All those kind of higher level words are metas, and then regular words are just other words are regular. So if you're a meta word, we always run you. If you're a regular word, you don't. You only get run if you're in run mode. I'm in North Carolina in the U.S. I don't know. I'm from various places in the U.S. How about you? Okay, so we're to the point we've got the notion of compile mode, and if you're in compile mode, we call the compiler. If you're not in compile mode, you're in evaluate mode, and we want to run this. And we're going to write a test for that, I think. REPL tests. Okay, so compile, eval all compiles. Okay, so Eval all calls meta even. Okay, Sweden and UK. Nice. Even in compile mode. Okay, so I guess we're going to, well, we're gonna do something like this. Let's see what we have, what we like from it. Oops. Test compile eval stack x19 move x24 compile mode. Okay, yeah, we want that to be compile mode. Eval word. Let's see what that is. A 1. Okay, we want test compile. Well, we have to make a dictionary. Dictionate. And then we're going to make a dictionary header. I'm going to take from this test. Yeah, this. And okay. Okay, so we have our real colon routine. Very professional. Okay. My best tie-dye on, I guess. Okay. So I'm creating a colon entry. It's marked as meta. I guess the thing is meta in run mode. Okay, I guess I need that second entry after all. The colon, semicolon. Okay, so colon defines methods and semicolon ends them. Okay, so if I were to run those two, let's see. Maybe I don't need this one. Okay, so we're going to put ourselves in compile mode to start with. Load address, let's say L colon. It'll make a label for that. Up here. I guess I'll do it closer to my test. L colon. It's going to be ASCII Z. Semicolon is what I want. No semicolon. Okay. All right. So we'll create this colon entry. X23, we're not going to compile anything, so we don't need this. Okay. And then at the end, I want to, I guess I want to look at X24. So I'll move X0 equals X24, which is the flag, global flag about compile mode. And X1 should be run mode. And then we'll assert that they're equal. So if semicolon gets executed, even though it's we don't have a compiler specified, so it should blow up if it tries. And we start out in compile mode. L address L colon. Semicolon. So we go in with the string. Okay. X19L eval test stack. I don't think we need that either for the test we're doing. No, I better not. Would defeat the purpose of the test. Okay, so we'll load the dictionary with the semicolon meta routine. The only thing it does right now is stop compile mode and put us back in run mode. So we'll force ourselves into compile mode. We'll load the address for x0 with the semicolon string, because it needs to know the string so it can run as meta on it. We'll eval, and then when we get back, x24 should be in run mode instead of compile mode. Okay, and let's call this. Now, I don't think I need x19 set, but it may complain about that first. We'll see. Well, even more. REPL tests needs, I guess, makefile. REPL test is going to need the dictionary. I guess that's true. REPL test depends on he has that. What's the complaint? Dictionary. Oh, it's not spelled like that. Who makes my thumbnail on YouTube videos? I do. Let's see. I have a script. I just use Magic, and that's an image editing tool. I tell it to resize 50% because for whatever reason my window creates 3840 by whatever, 3820 by 2160. I reduce the quality because it's going to be a little tiny JPEG thing, so I don't really need much. So you're welcome to copy that script and do what you want with it. Give you 3 seconds for a screenshot. 1, 2, 3. Okay. Let's see. So dictionary init, throw the semicolon in, set compile mode, call set x0 ready to call with the semicolon label. Eval all should call this routine even though it's in compile mode. And when it gets back, it should be in run mode. Okay, so I believe that should fail, like you say. Okay. Let's see. So x0 equals 1. It should be 0. Yeah, so it didn't do anything. As expected, I guess. Where's REPL? Okay, so I don't know what was wrong with what I did before. All right. If I'm in compile mode, okay, so I check that the last bit basically is in compile mode. I look at it. If it's ANDed with compile mode and it's a 0, it's going to be false 0, and if it's 1, it should be 1. It should be equal. If they're not equal, if I'm not in compile mode, I want to go evaluate. That makes sense to me. Okay, otherwise I call the compiler in x23. Either way, I end up at the end of the routine. Okay, now I thought this code should be okay. So x0 comes in. Oh, I didn't restore x0. Okay, so I call isMeta. That's going to take x0 and return x0 being a true or false, whether it's meta or not. but either way, I hate to my BEQ, I can't really separate. Well, okay, if I'll move x0 gets x28, and I'll do the same thing in both branches. Oh, I can, no, I can't. x28. Okay, because x28 is just a temp holding x0, even when I call other routines. Okay, no, not on Discord. I mean, I have an account and I log in once a month or something. All right. It just became one more social network thing to look at, and I couldn't do it. If there's somebody I'm going to and they really have a discussion going on it, then I might pop in, but otherwise not really. All right, so now x0 is back to what it started with, and we can do BLR to the compiler, and here same thing. Maybe I can, I don't know if I do a move, I think I'm going to destroy the bits that this represents. So let's see if this works, and then we can debate improving it. Okay, that's good. Oh, digital artist. Okay. Well, I'll warn you, the last 3 digital artists basically came in here, had a discussion because they wanted to sell me some art, and I'm probably not buying. But you're welcome here. But our topic is more programming than art. Okay. So apparently that works. Let's run the REPL. And again, one dupe colon multiply add. Okay, so that should break if I'm not doing the right thing. Oh, I'm still not getting it. Did it multiply? Can you share ideas? I guess a little bit, but a little off page from juggling assembly language here. Okay, so what I was expecting was one dupe add to be the ones that run, and multiply to be just ignored. I guess if we run the REPL and stop after every word and figure out whether we're in the compiler mode or execution mode, it seems like we're not running that last word. Okay. Am I on Instagram? No. Okay. So I guess a quick look might be worth it. Is there some reason it would? Well, oh wait. We did not set up the main. I don't think we have to do word not found error because we kind of find that a different way. All right. Make REPL. Okay. So it was one dupe colon mul semicolon add, and we want a 2. Hey, there it is. Okay. Make REPL now runs metas even in compile mode. Can you talk on Instagram? No. I don't mess with that at all. All right. Whoops. I guess I meant ACP. Very good. All right. Okay, so I think that puts us at a kind of consistent point. I haven't updated this at all today. Let's do that. St. Patrick's Day this weekend. Meta routines. Okay, so we've done the meta routines. Develop a way to recognize meta words. This is kind of, well, it's kind of compiler. And then make REPL call metas even in compile mode. Okay. Yeah. This might be the only shirt with any green in it. Okay. Let's see. Develop a way to write. I think we're to the point where we can start doing secondaries. So let's go back to main for a moment. So as of now, we have 3 out of the 4 arithmetics, 1 logical test of relations, 1 printing thing, I guess I've been alphabetical here. Okay. I don't do anything with alphabetical, but okay. And our colon and semicolon. Right. Okay. So this kind of goes back to this picture. And so if I say start secondary, that's what happens in the colon routine. So I'm sort of assuming there's a free space block where the secondaries are going to be written, and also where their names are going to be put, and I don't know what else, maybe there's another block, still another block for the names. Probably has to be. Okay, so but somehow currently we have the system dictionary set up at the very start of the thing, and then I think we're going to have another block where the secondary dictionaries are, and we need to we're going to start writing a header. So the first thing in the header is the pointer to the previous entry on the system dictionary, and we'll write that in the first slot. Then we're going to put the name somewhere, and then write the address of that name as our next block. And then we're going to write the address of start2d, which is a known thing. And you get that when you call colon. I think its only job is to read, well, it sets compile mode, and it reads the next word, and that's the name it saves. And that name is gone at that point. Now we might move the dictionary header forward here, because I'm thinking about recursive routines. If you're in compile mode and the word does not exist, yeah, you could check that. I don't think we're going to. I'm going to say you can overwrite a word with a new definition. And because we always search the most recently added words first, that's fine. Again, this is kind of one of those things, if I were doing this for a real, a language I really wanted other people to use, and I would really define my semantics a little more carefully. And I would probably say colon followed by a word you already know is an error. It could be an error. Okay. But I'm going to say you can redeclare it, and it'll be there first. Now, fourth, they actually build their dictionary as trees. So you start with a primary dictionary, and then you can extend and say, here's this other dictionary I want in front, and then you can split off from that, and then attach another dictionary in front of those two, and then a different dictionary in front of the original two without touching that third dictionary and stuff like that. So it gives them more of a module kind of space. I mean, it's not It's not what you think of as a module in most programming languages, but it gives you that sort of effect. And there, your module might want to rewrite a word so that something happens differently in that module. Kind of like our meta and dictionary, right? We do two things in our metas. We do two things when we set up a dictionary entry. We write some stuff over here for the name and write some stuff over there for the meta, and then write some stuff in the dictionary, so it goes multiple places. And I could imagine sort of like, there's something like this in JavaScript, right? Where you can kind of like, or languages with a superclass you can call super or that sort of thing. That would sort of be like skipping your dictionary and starting in, at a dictionary that's lower down, and then the original definition of the word would be there, or something like that. So they do it that way to support this module notion. I'm just going to have one dictionary and not worry about it. In some ways, when we finish this stuff with creating secondaries, we then have the ability to create primaries, create secondaries at runtime, interpret primaries, interpret secondaries, both those at runtime. And that's sort of a complete environment in some sense. Now, half a dozen words is not going to be enough vocabulary to do much, so I will bulk that out. But, that's about as far as I'm going to go with it. Yeah. Well, the module thing might be a little chaotic. Yeah. I think think of it more like calling super, though. I think you would, instead of looking up a word in your dictionary, you would look it up in the parent dictionary, kind of thing. So is it duct taping inheritance? Yeah, maybe so, a little bit. Yeah, but you definitely could have different words doing different things in different dictionaries. But I think you have the ability to wrap. So if I wanted to add behavior to a word, maybe I want certain words every time you call them. I want to print some stuff, debugging information before and after. I could introduce a word with debugging stuff, and then probably I would probably add a delete word, in my vocabulary, so I could get rid of one of these, and I do that by moving the pointer that points to it, skip over it or something, So you could build up something that does gives you some capabilities on those lines. It's perfectly reasonable that Forth does what they do. I think. It's kind of, in a way, it's a little kludgy, but it's in their their spirit, I guess you'd say. But I'm gonna keep our language a little more minimal and not worry about that too much. So I'm not going to make our dictionary go dig out and say, is this name defined? But I do want to make it available for recursive calls. So we probably need to do this update over here. And really, update is going to find the word in the dictionary and get the pointer to the word address that may or may not exist yet. I guess it will. It will exist by here, because this address is the word address, the word we're defining. So, yeah. Add instructions to a word if it exists. Yeah. It's more. I think you could be more in that spirit with a little bit of support. Okay. So, how far to go? Well, so I think start secondary is the job of the colon routine. So its thing is read a word, and read a word and create its dictionary entry. And then the compile routine in the middle of the REPL, it does the add secondary, which is write a word address to the free word. So look it up in the dictionary, get the word address, and then write that into the list. And then secondary is sort of the same thing. We just assume it's N2D, and that's going to be called by the semicolon, and also reset compile mode. Okay. Now, what's not as clear to me Well, okay. I mean, I don't have a problem creating a namespace for now. We need to deal with strings at some point. But I don't think these strings are in the user space, so I don't think I'm going to worry about that. I'll just create an area. We'll need an extra free pointer. Secondary could be a constant. Yeah. So if you wanted to have a constant, I mean, 1 is 1 in every base, so that's why they define it as a routine. But a secondary could say 4, and in compile mode, that should turn into underscore push followed by a word for in our secondary list. So they can have, they do have some work to do. Now, whether who's doing that? Yeah, variables, same thing. We got to work out how to create variables. But I think what fourth does is it puts them in the dictionary, and then I think they just have one thing in their secondary, maybe, or maybe they have the word variable and then the secondary, then the value in the secondary. So if you define X to be 1, we'll create an entry for X in the dictionary wise, and then I think the method is probably sort of like start secondary, but it knows it's just dealing with a variable value. And so when you ask for that variable, it just pushes it on the stack. And when you write it, there's going to be yet another word that is going to take that variable and store it somewhere. So yeah, there's gonna be some work in some of these. I think a lot of them, I mean, like the multiply and all those guys, the numeric operations, they're very straightforward. It's just, take top of the stack, second on the stack, do some operation and push the result. Or maybe there's a div mod that does both div and mod, and it calculates both results or whatever. Those are pretty straightforward. The variables are going to be tricky. Strings are going to be tricky. Arrays are going to be tricky. Control structures are going to be tricky. We've done a lot of work for the control structures. We've got the mechanism to branch and jump if not equal and stuff like that. So it's more writing the word for if and the word for end that creates those in the secondary that's going to be the thing. Okay. So I guess the deal is we're asking a lot of, I don't know, I almost want to do them backwards, right? Like let semicolon append to the latest word, Okay, let's do that. So semicolon has 2 jobs. It's going to do this, and it's going to restore run mode. Okay, and I mean, we don't have time to do more than sketch out the test, but that's all right. Tomorrow we work on these secondaries, or sorry, Monday. It's already Thursday. All right, next week we'll get those secondaries. I think that'll take us a session or 2. And at that point, we're going to bulk out these things. I mean, they're very straightforward to test. They're very straightforward to write. Most of them, all the computational ones. Working on the ifs and the elses and the repeats and all that stuff's going to be a bit more. So we'll deal with those. I mean, we'll deal, but they're going to be more work. Okay. And your push, your literal, that's going to be another one that's like that. Okay. So the test is, if we set a free variable somewhere and we write the word address of N2D, I guess we're just going to make sure N2D shows up in that address. Okay. That's pretty simple. Alrighty. That test is, I guess that's a core. because that's semicolon's job. So back to core tests. I'll close some of these. Okay, so core tests. Let's see, there's colon, there's semicolon. Semicolon writes into D in secondary. Yeah, we need to initialize free, but I think, well, how are we doing on registers? We've got some more. I think my weekend project, I'm going to pull together all these little design notes and do them, pull them into one file that we can look at. Yeah, so we can, I'm assuming this will be a register. And as a matter of fact, let's say x25 is free equals next secondary cell. Okay. Maybe it's not free. Maybe it's like secondary space. Okay. So there's a decision. So x25, let's set x25 spec space somewhere. Call semicolon. Verify that sec space increased by 8 bytes. And verify that sec space, verify that N2D's word address is in the previous cell. Okay. And yeah, so we'll point that somewhere, call semicolon, verify that it wrote it where we told it to, and that it incremented. I don't know. This maybe I'll swap. Yeah. Might be, I don't know, it might be easier to test it in the other order. All right, but I think that'll give us a place to start on Monday. And I'll just put something that's almost certainly going to fail. Well, what do I know? Oh, I didn't call it. Okay, let's call it. Okay. Yeah, so we got a failing test in there. All right, so Monday it's 2 to 4:30 Eastern Daylight Time, and that's UTC 6 to 8:30 p.m. I don't know. Are you on daylight savings next week, Mudshark? Maybe your timing may change. I don't remember when Europe switches. All right, but we made some progress this week. I'm happy with where we are. It's once we get this colon and semicolon going, we really have a complete language in some sense. It doesn't do enough, but that we have the facility to create the rest of it very, very easily. And then once we have it, I want to create a package. It's either going to be a calculator of some sort or a game of some sort, just enough to demonstrate that, just enough to demonstrate the language is complete enough to do a real job. All right. You got a couple weeks to go yet. All right. Take care. Have a good weekend, and I'll see you Monday or some other time. Bye-bye.